Hey everybody, welcome back. Mr. Gajewski here. Today we're going to talk about lesson 2.1.2. What is the perimeter? Simplifying expressions by combining like terms. Well, in lesson 2.1.1, focused on the area of algebra tiles. Today's lesson will focus on the perimeter. What is perimeter? How can you find it? By the end of this lesson, you will be able to find the perimeter of complex shapes formed by collections of tiles. Your class will also focus on several ways to find perimeter, recognizing that there are different ways to see or recognize perimeter. Sometimes with complex shapes, a convenient shortcut can help you find the perimeter more quickly. Be sure to share any insight into finding perimeter with your teammates and with the whole class. While working today, ask yourself and your teammates these focus questions. How did you see it? How can you write it? Is your expression as simplified as possible? All right, so 211, your teacher will provide a set of algebra tiles for your team to use today. Separate one of each shape and review its name, the area, then find the perimeter of each tile. Decide with your team how to write a simplified expression that represents the perimeter of each tile. Be prepared to share the perimeters you find with the class. So you are not going to have the algebra tiles if you are working virtually, but you can have and can use the e-tools. I'm going to go ahead and pull those up a little bit here. All right, and you should have in your notebook somewhere these tiles sketched. All right. So if we look at this first one here, this is the X tile, and I want to know the perimeter. So remember, the perimeter is the sum of all the sides added up, and the sides of this shape, of this tile, are x, 1, x, and 1. So the perimeter here is equal to x plus 1 plus 1. Well, if I go ahead and combine the x's with the x's, the ones with the ones, the perimeter of this tile is 2x plus 2. Go ahead and try the same with the y tile, 1 tile, x squared, y squared, and xy tile. Pause the video, please. Give it a go on your own. All right, everybody, welcome back. Hopefully you went and tried some of these on your own. I'm going to go ahead and go through the rest of them with you. All right, the y tile has a perimeter of 1, 2 y's plus 2 unit tiles. The unit tile has a perimeter of 4. The x squared tile, well, that has a perimeter of 4x. I add up all the sides, 1, 2, 3, 4 x's. And y squared is going to be very similar. Perimeter is equal to 1, 2, 3, 4 y's. And then lastly, the xy. The shorter sides are going to be the x's. The longer sides are the y's. That's x plus y plus y. How many x's? 2. How many y's? 2. So that is the perimeter of each individual shape. I'm going to go ahead and flip back to the book. Virtual friends, you can do 212 if you'd like, matching the letter column to the number column. You do not have to do that. That is not one of our core problems. Let's take a look at 213 for each of the shapes formed by algebra tiles below. Use tiles to build the shapes. I'm not going to make you do that. Sketch and label the shape on your paper, then write an expression that represents the perimeter. Simplify your perimeter expression as much as possible. This process of writing the expression more simply by collecting together the parts of the expression that are the same is called combining like terms. If you want to learn more about like terms, you can read here. A synopsis of it would be like terms. Same variables raised to the same power. Okay. I'm not going to make you build, but I am going to ask that you sketch and label each of these on your paper. So go ahead, pause the video, take a minute here. For A, B, and C, you don't have to do D. Go ahead and sketch those on your paper. All right, let's go ahead and label these up here, and then we will write an expression for the perimeter. So I'm going to go ahead and annotate again. So remember, these unit tiles have lengths of 1, have an x, a 1, a y, a 1, an x, and x. So for my perimeter here, I have 1, 2, 3, 4 x's, 1, 2 y's, and 1, 2, 3, 4, 5, 6 unit tiles. Let's take a look at B. It has a length of 1, 1, 1, 1, x, and 1. Now this whole side would be x, but we're not counting this 1. So this part is actually x minus 1, minus this little portion down here. So if I were to go ahead and add up all these sides, I have x plus 1 plus x minus 1 plus 1, 2, 3, 4. So 1, 2, 3, 4. I go ahead and simplify here. Well, how many x's do I have? 1, 2, so that's 2x. Then I have plus 1, 2, 3, 4, 5, plus 5 minus 1. Ooh, and I can simplify that further. 5 minus 1, I get 4. So here is my simplified version, 2x plus 4. And lastly, let's take a look at C here. Again, I'm labeling the sides. Right, and in here, this whole side length is y. We need to take away the x. So here we have y minus x. And then this side here is x, but we want to take away the 1. So that's going to be an x minus 1. Let's go ahead and let's add these together. Y plus y plus y plus x plus 1 plus 1 plus 1 plus x minus 1, ooh, running out of room, plus y minus x. And I'll just write right over the top here, plus y minus x. All right, let's go ahead and let's round up all of our x's here. So I have 1, 2, 3. So plus x plus x plus x minus x. So I have plus 3x minus x plus 1, 2, 3, 4 y's plus 1, 2, 3 plus 3 minus 1. Okay, well 3x minus x is going to be 2x plus 4y plus 2. That would be my perimeter for 13C. You do not have to do part D. All right, 214, calculate the perimeter of the shapes in problem 213. If the perimeter of each X tile is 3 units, and the length of each Y tile is 8 units. So I'm going to go ahead and open up a new tab. I'm going to relabel each of these shapes and write down the given value. So I have, let's see here, we have x equals 3, y equals 8. So I'm going to go ahead and jump. All right, where's my first one? 4x plus 2y plus 6. All right, 4x plus 2y plus 6. And I'm saying, well, x equals 3 and y equals 8. So we have 4 times x, which is 3, plus 2 times y, which is 8, plus 6. Order of operations, I'm going to go ahead and multiply 12 plus 16 plus 6. 12 plus 16, I get 28. 28 plus 6, I get 34. As I jump back to my first tab, all right, B, 2x plus 4. So, same thing. 2x plus 4. We say x is equal to 3. So I substitute a 3 for x. Order of operations, 2 times 3 is 6. Plus 4, I get 10. So the perimeter for B is 10. Okay, let's go ahead and I'm going to have to clear this. Actually, let's see if I hit this. Yep, there we go. All right, part C then. All right, C, what was our equation? 2x plus 4y plus 2. 2x plus 4y plus 2. All right, well, we said x equals 3, y equals 8. We're going to put a 3 in for x, so 2 times 3 plus 4 times 8 plus 2. Well, 2 times 3, I get 6. 4 times 8, I get 32 plus 2. Add them up. 6 plus 32, I get 38. 38 plus 2, I get 40. Gonna go ahead and jump on back, scroll down a little bit. 215 is an extension. You do not have to do that. But do take a look at the learning log. So in your learning log, create your own shape using 3 different shaped tiles. Draw the shape and show how to write a simplified expression for its perimeter. Label this entry, finding the perimeter and combining like terms. And include today's date. That's going to take me, learn something new. All right, but that is it for our lesson today. Thank you for watching. I'll see you next time.